So this is the first problem of yesterday's educational round. And in this problem, we are given that there is a ribbon divided into n cells numbered from 1 to n. Now from each left to right, each cell either contains a chip or is free. So you can perform the following operations any number of times. Choose a chip and move it to the closest free cell to the left. And you can choose any chip that you want. So provided that there is at least one free cell to the left of it, so then only we can move it. And when you move a chip, the cell where it was becomes free. So our goal is to the minimum number of moves or minimum number of operations required such that all the chips form a single block without any free cells in between. So let me take an example. So let's take first of all, let's take the first example. In this, we are given that we have 8 cells and the cells look like this. So see, first of all, one thing that we need to understand is there is no point in moving this first cell, because see, we can only move these towards left, that is towards first left free cell. So there is no point to move this chip because then we'll have to move every other chip. So this remains here. Similarly, these two will also remain here. Now, one thing that we can do is one by one we can move these chips, but that will give us the answer as 2. Better way to do this is just move directly this chip to the cell which is free. So that way our answer will be 1. So what I'm doing, see, you'll have something like this every time. There will be some zeros followed by blocks of 1, followed by some zeros again. So what we need to do, we'll start from this point, the last one, and we'll always move it to the 0 which is at front of its block. Then we'll move this. So at this point we'll have this block. Then we'll move this one here. So and then this one here. So at this point we'll have something like 1 1 1 1 1 5 ones, 4 of these and 1 of this. Now there are these 3 ones also, so something like 1 1 1 and 5 more ones. So there's these 3 and 5 more. So then again we'll move this one, last one, to the first 0 at the front of the block and this here. So how many moves are there? 1 2 3 4 5 6. So what I'm actually doing is, see, every 0 from between first one to last one, every 0 in between will have like all moves. In all moves there will be a 0, or let's say a free position covered between first one and last one. So this is like how you can visualize what is happening, and this is actually what is going to happen. So from this we can directly see that what should be our answer. What is the minimum number of moves? It's just the what is the count of these zeros between last one and first one. Is it making sense? And like if you want to visualize it, this is what will happen. Like from the last, like whatever the last one is, it will be shifted to the first, or like the closest 0 or the closest free position which is in front of its block, not the complete front, just the front of its block. Is it clear? Yes, no? What about others? Okay. So let me show you the implementation. So this is the implementation. See, first I'm taking n as input, then I'm taking the array a as input. This is my final answer value, and this is the number of ones that I have currently seen. And this is the total number of ones in my array. So see, there are many ways to do this. Either you can just go to the first index, like the first place which is having a 1, and then from there iterate to the last one. But what I have done, I have like initialized these two. I have declared these two variables, 1 and count. So what I'll do, if I encounter a 1, I'll increase my 1, like this value by 1. And otherwise, if I already have a value of 1 as more than 0, then this means that I've already encountered my first one. So then in case I have a 0, I'll include it in my answer because I'm counting all the zeros in between first one and last one. And if my 1 becomes equals to count, that means I have iterated through over all my zeros that lie in between first one and last one. So I can simply break this loop. I don't have to count the zeros which are beyond the last one. Finally, I can print my answer. Is it clear? Is anyone having any doubt in the implementation? Yes, no? Okay, so let's go to the next problem. So in the next problem, we are given that we are playing a computer game and the current level of the game can be modeled as a straight line. So our character is in point 0 of this line and there are n monsters trying to kill our character. So the ith monster has health equals to AI and is initially in the point xi. So every second the following thing happens. First, we fire up to k bullets at a monster. Now each bullet targets exactly one monster and decreases its health by 1. And for each bullet, we can choose its target arbitrarily. Like we can choose whether we'll hit 1 with all the bullets, one monster, or we'll hit like one monster will get 2 bullets, another monster will get 3 bullets, another monster will get 1 bullet. So we can decide arbitrarily. And then after this thing, all the alive monsters whose health becomes 0 or less, they die. Then all alive monsters move 1 point closer to us, and if any monster reaches the point 0, that is where our character is, we die. So we need to find whether our character can survive all survive this like by killing all the n monsters before they reach us. So let's take an example. Let's take the first and let's take first and fourth example. So see, in first example we are given that we have n as 3 and we have k as 2. So there will be 3 monsters and at max every minute we can shoot up to 2 bullets. And the health of these monsters are 1, 2, and 3. And x, the positions at which these monsters are is -1, 2, and 3. So the first thing that we need to understand is this being -1 or 1 is same. See, we are at x equals to 0. This is x equals to 0. And this is the number line. So monsters approaching from this side and this side have the same. Like if a monster is at -2 or if a monster is at 2, like they'll reach us at t is equals to 2 only. So instead of taking like 2 monsters this side, 1 monster this side, we can say that all the 3 monsters are on this side only. Right? This is the same thing because we'll be shooting bullets arbitrarily. Like it's not about like shooting left once, shooting right in next move. So is this making sense? Is this clear to everyone? Okay. And now the second thing is that once like once what we can do first of all is like let's take this test case only. We'll take the monster's positions as 1, 2, and 3. So we are at x equals to 0. There's a monster at 1. There's a monster at 2. There's a monster at 3. The power of the health of this is 1. The health of this is 2. The health of this is 3. We can shoot up to 2 bullets at a time. So at first bullet, this becomes 0 and this becomes 1. Like one bullet hits this and one bullet hits this. So this is my second point, right? Since we can hit each monster with arbitrary number of bullets, we'll never hit a monster such that its health becomes less than 0. Like why will you hit a monster with more number of bullets than it's required, right? Is this thing making sense to everyone that there is like never, this case is never optimal that you hit a monster with more number of bullets than its actual health. Okay, so now at like for first bullet this happens. Now for second bullet, this health will become 0 and this will become 2. Like one bullet will hit this, and at time 3 this bullet will hit, like all the 2 bullets will hit this and become 0. So see, at first time equals to 1, this bullet hits this monster and this monster dies. So this monster cannot reach x equals to 0. Similarly, for time 1, this monster's health was 1. So this monster would have reached here. But at time equals to 2, its health becomes 0. So this monster also cannot reach x equals to 0. Similarly, for this monster, at time equals to 1, this monsters reach this point with health 3. Then at time equals to 2, this monster reaches here with health 2. And then at t equals to 3, its health becomes 0. So that monster can also not reach x equals to 0. So that's why our answer is yes. Is it making sense? In case the health of this monster would have been 4, then what would have been our answer? No, right? So is this clear to everyone? Like why no? Okay. Now looking at the problem constraint, x is between, every xi is between minus n and n. And this is for every I between like 1 and n. So for every monster, xi is between this thing. So like I said, we can align monsters on only one side. So this is x equals to 0. So every monster is between on these points from 1 to n. Is it making sense? So what we can do, like we can say that for every position we have k rounds. Like they will be only like k rounds at max that we will do. Like k rounds of bullets is at max that we can shoot. Why? Because anyway, if the monsters are not dead in k rounds, one of them will surely reach us. So there are k rounds for every position, and there are total n, like there are k bullets for n positions. So there will be n rounds, and in each round we'll shoot k bullets. So k for this, 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 k for this. So initially my total, like how many bullets I have shooted is 0. I shooted k bullets. My total becomes k. Now this is the total number of bullets that are passing through this point. So if I check that if my total is more than or equals to the total number of monsters health, not individual, like number of, not, I'm not saying number of monsters, I'm saying total number of monsters health that are present here. It can be something like A2 monster was here and A5 monster was here, because x of 2 and x of 5 are both equals to 1. So the sum of these is less. If this is less than total this sum, then I can kill both the monsters in time, right? And let's say if this sum was less than total, then some of my bullets can pass through this thing and will reach this position also. So I'll subtract whatever I have to subtract from here. Let's say I subtracted this. This is my total now. And here I'll add this K again. Like this was the remaining number of bullets from first question. I'll add K again and I'll check the same thing. Whether my total is more than or equals to the sum at this point or not. The sum of health of all the monsters at this point. In case at any point I find that this is less, total is less than sum, my answer will be straightforward no. That because those monsters will definitely reach me. Some of them will have health more than 0 when they reach this point. Is it making sense? Otherwise, I'll iterate through from 1 to n. Okay, how the total is being calculated? See, total is nothing but how many bullets are reaching this point. So initially, like total will also have accumulated value from past positions which didn't got used up. So initially total is 0. Then, so initially total is 0. Then in first position, I'll add K to this. And I'll check whether the bullets that are required at this point is more than or less than total. In case total is more than or equals to the sum of healths present at this point, sum 1. If this is the case, then I'll simply deduct my bullets, like from total number of bullets, I'll deduct sum 1 number of bullets because those will be required to kill the monsters on this position. And I'll go ahead, I'll add K to my total. Why? Because I have K more bullets now. So I'll again add K and then I again check the same thing, but with sum 2. Now, if at this point I find that the total number of bullets that I have for this position is less than sum 2, then my answer is no. Otherwise, I'll continue and go to the next position. Is it clear now? Is it clear? Yes, no? Okay. So can we move to the implementation part? Okay. So this is the implementation. In this, I have declared first n and k. This is the number of monsters that I have, and this is the total number of bullets that can be shooted at each instance. So I'm taking the health of every monster first in input. Then this is the total number of monsters that will be at every position. So I'm going like I'm taking X as input. Then this is the position of the ith monster. So be at absolute position of X. Why? -1 and 1 mean the same thing. And plus this health. So this is basically B of I is equals to sum of I. Like all the sum of every monster's health at ith position. F equals like this is my check. If F is finally 1, my answer is yes. Otherwise, my answer is no. This is the remaining number of bullets. Like instead of total, I'm taking remaining here. Like they have the same meaning. So first of all, I reach the ith position. I can have some remaining number of bullets initially also. So I'm taking the minimum of the health that the monster is having currently and my remaining number of bullets. So this is the temporary value. I subtract it from both. Now, if after this point also, like I have used all the remaining value, like bullets. So same meaning, like if the total number of health that is left with the monsters right now is more than K, because I can have only K bullets right now. Like I can write this like I explained also. See, what we are doing, we are adding in remain total number of bullets that we have remaining right now, we'll add K. And if remaining is less than the total number of health that I have here, then my F becomes 0, like the check value becomes 0. Otherwise, what I can do is just simply decrease from remaining. I can just simply decrease B of I. Like this is what I was doing here also. If B of I is more than K, but I was adding K later on, like K minus BI. Is it clear? This is what I explained, right? And finally, we can check that if if I have like F is 1, that is the check is 1, then my answer is yes. Otherwise, my answer is no. Is it clear? Okay. Nobody is having any doubt in the implementation, right? Okay, so let's go to the next problem. So this is the next problem, and in this problem we're given that an array of length m is considered good if there exists an integer array b of length m such that the following two conditions hold. The sum of all the elements from 1 to m in array A is same as the sum of elements in array B from 1 to m. But no position in both arrays has the same value. Like AI is not equals to BI for every index from 1 to m, and BI needs to be positive. Like it shouldn't be 0 or negative. It needs to be positive only for every index from 1 to m. So given an array C of length n, where each index in this array is more than 0, we need to answer Q queries like and the ith query will be like we have to determine whether the subarray from L to R in C is good or not. So let's take an example. Let's take this complete thing. So in this example, C, the array C is 1, 2, 1, 4, and 5. And in first we have like the subarray is 1 to 5. Like the complete array is given as subarray. So whether we have to find whether there exists another array B for which we have the same sum, but the elements are not same as these as any position, and the element in the new array, every element is positive. So what I can do is I can write 2 here, 1 here. What should I write here? Let's say 2. Let's say I write 3 here. So what is the sum that I have? 2, 5, 6. And I can write here 3 and here 4. So what is the total sum of this array? 13, right? And what is the sum of this? 13. So you see, none of the elements in these two arrays are same. The sum of them is equal, and none of the elements in this array is 0 or less. Like it's positive, right? So that's why the answer for first query is yes. Is it making sense? Yes, no? Now what about the second query? In the second query, we have this 4, 4. So just this subarray. So for this, if we have just one element and we want the sum same as this, we'll have to have that element only. But that violates our second condition that the elements cannot be same. So that's why the answer for every subarray of size 1 will be no. Right? What about the third query? Can you tell me the answer for the third query? That is 3 to 4. There are two elements, 3, 4, 5 in that subarray. So what should be the answer for that? If you have those two elements, then 4 and 5, what we can do, we can create another subarray array with 5, 4. The sum of these will be equal. Elements are different, and none of the elements in this is negative or 0. So the answer for this is yes. What about the last query? What about this query? So this is a little tricky, and this is basically that you require to solve this problem. That is, you have 1, 2, 1 as your subarray. See, you require 4 as the sum, and you cannot have more than, like, you cannot have negative elements. So if you need 4 as sum, at least 2 elements will be 1 and 1 element will be 2. Why? Because you cannot have negative elements and you cannot have elements less than or equals to 0. So if that is the case, you can have at least, like, you need to have at least 2 1s and a 1 2. So no way, like, there are 3 ways you can arrange this. In all of these 3, you will find a position at which a value from this thing, like a value from this subarray or any of these, like, there will be a position at which the value will be same in this thing and these also, for any of these, for all 3s. So the answer for this is always no. Like, you cannot have a new subarray for which the sum is also same and the values are different. Is it clear? The value at every position is different. Is it clear? Yes, no? So now, looking at this thing only, like, how can we come up with an answer? See, if the values are more than 1, see, every value in your subarray is more than 1. Doesn't matter if everything is 2 also. What you can do for the first n minus 1 positions, you can have 1, and then for the last position, you can have everything, like whatever is left, like 2 minus 1, 3 minus 1, 4 minus 1, 3 minus 1, 2 minus 1, 2 minus 1, 2 minus 1, and this complete 2. And you add everything and you write here. So the answer is possible for every subarray which is not having ones. But when there are ones, the situation becomes a little tricky. How? Because for all the ones, and let's say there are some x, y, z, x, y, z, okay? For every one, you need to have 2 only, right? Yes, no? Because you cannot have value less than this. You need to have 2. Now the thing is, this is left. X plus y plus z is left. And what is the minimum that you can have here? Minimum that you can have here is 1 1 1. So the thing is, if x plus y plus z is more than or equals to 3, you are good to go. But if this thing is less than 3, your answer is it making sense? Okay, what is the doubt in this? Like, what is, like, the thing that you are not able to understand in this? Like, we can make sum as same by the same thing, that we'll keep 1 1 1 here and the remaining thing will come here. Otherwise, if, let's say, like, these 2 places are not having ones, right? Like, I have to make the sum of complete things same, not just this thing. I think you're getting confused. I don't have to make sum of these parts just same. I have to make the sum of complete thing. So even though I have 2's in places of 1, I'll manage it here. I'll have 1 1 and the remaining will go here. Like, I'll give you an example. Let's say the original was 1 1 1 1 1. And yes, I'll give you an example. And I had 3 2 5. So I'll have 2 2 2 2 here. X plus y, no, this thing is just like x plus y, no, x plus y, this was just like I was writing here. See, what is the total sum for this? 5 6 7 8 9 10 11 12 13 14. And what is the value that you have come up with here? You have 2 plus 2 plus 2 plus 2. That is the minimum. Like I was writing just minimum, but the value that you have up till now is 8. So 14 minus 8, this is what you have already done till now. So this is left, you're left with 6. So this thing should be more than 6, not 3. The sum of this part should be more than 6. Like you need to have 6 here. If you need to have 6 here, the thing is, like these numbers, like these positions, how many positions are you left with? You're left with 3 positions. This 3 should be more than equals to 6. Like what is the sum that you're left with? This is the sum. This is the remaining thing. And how many positions are you left with? This is the positions left. So positions left minus remaining should be more than equals to 0. Why? Because every position will have a minimum of one value only. So position should be more than or equals to rem. Is it now making sense? What I'm trying to say? Remaining should be more than position, sorry. Remaining should be more than or equals to positions, not the other way around. Because every position can have like 1, 2, 3, but every position cannot have, like positions cannot have 0 or minus 1. This is clear, right? This is the remaining sum, and this is the number of positions that are left apart from the positions which were having 1. Is it clear now? Then the answer is possible. I'm sorry, like I got confused, like I said something wrong here, I think. This is the case, that remaining should be more than positions left. So let me show you the implementation. So in this, I have first taken n number of elements and number of queries as input. This is my array A. This is for prefix sum, and this is from prefix sum of ones. Like how many, like how can I count what are the number of ones in a range quickly? So that is using prefix sum. This is for finding the sum of in range. So this is prefix sum, and this is array A1. Like how many ones are in a range in array A. Then I'm taking input and I am computing my values for prefix and 1, and then I take prefix sum for both of these. Now for each query, I'm taking L and R as input. If my L is equals to R, then there is just one element in my range, in my subarray. So I'll print no. Otherwise, I calculate the sum of this subarray and the number of ones that are in this subarray. Finally, from my subarray, all the positions, that is this count, which are having 1, in those positions, I have 2. So my remaining thing is this thing. Remaining sum is this thing. And the positions left is, this was the total number of elements in the range minus the positions that have 1. So this is the remaining number of positions, and this is the remaining sum. If the remaining sum is more than the remaining positions, my answer is yes, otherwise my answer is no. Is it clear? What about others? Yeah, you can do it like that also. Okay. So let's go to the next problem. So in this problem, we are given that there are n slimes placed in a line, and the slimes are numbered from 1 to n in order of left to right. The size of the ith slime is ai, and every second the following happens. Exactly one slime gets eaten and its neighbors in by one of its neighbors. Each, like every slime eats one of its neighbors and increases its size by the eaten neighbor size. So a slime can eat its neighbor only if the it is strictly bigger than the neighbor. If there is no slime which is strictly bigger than one of its neighbors, the process ends. So for example, this thing, I'll take this example, 2, 2, 3, 1, 4. So let's say we have the example 2, 2, 3, 1, and 4. So we have to find like what is the minimum time across all arrangements, or like across all possibilities for ith slime when it will get eaten for the first time, like we're at the minimum time. So one of the possible ways is to, like, how what can happen, the third slime eats this, then this thing becomes 5, then it eats this thing will become 7, then it eats this will become 8, and then this will be eat 4. Here it is eating 1, here it is eating 2. Okay, so completely 9. So one way is this. In this, the times that we got is 1, 2, 3, 4. The another way was that this got first eaten like here, then maybe here, and then here. So this way, the time for this would have been 1, and the time for this, like these are the times, right? So that way, I would have received time for this as 1 and this as 2. So if you look at the test case, the answer, the the answer for this would be, what should be the answer for this? It would be like 2 for the first line, 1 for the second. This could be eaten. Like, okay, I cannot eat after eating this. I cannot eat this. No, I can eat this. I can first eat this. So 1, so 4, then 2, and then this. Okay, yes, 2. So 2 for this, and I can eat like this. Last can eat this, and then they combined can eat this. So 2 for this and 1 for this. This is the time, right? Minimum time in which every slime will be getting eaten. Is this thing clear to everyone? So this is a little bit tricky problem, but if you have solved problems like this before, there's a straight way forward way to like a straightforward way to solve this problem. So yes, binary search, but yes, binary search is actually what we'll do. But how do we, like, what, first of all, try to identify on what thing we need to apply binary search. On what thing do we have to apply binary search? Yes, prefix sum. And one more thing, like that is you are only considering slimes to be getting eaten from left side, like from left to right. What about the other way? So let me explain. See, okay, what about others? Like try to think like like binary search is okay, but how do we, like, on what thing we need to apply binary search, and how do we need to apply this? Okay, let me explain. Let me explain. See, we need to apply binary search, but we need to apply, like let's say this is what we have and we are looking for this. So we need to apply it 2 times. Like what is the closest slime that can eat everything from here to here and eventually come here, and what is the closest slime on right side that can eat every slime and come to this position, and we'll take minimum of these. So how to find this? The first thing is the sum of this thing. The sum of these slimes should be more than this slime. The value for all of these slimes added up should be more than this thing. Yes, no. And the second thing is, how will this chain reaction start? How will this, like, first one will eat another, then it will eat another. But how will this start? Like, there is one thing that needs to be there. All of these shouldn't be same. There should at least be one different. If everything is same, even though this combined is more than this line, let's take this example, 1, 1, 1, 2. Even though all of these three combined is more than this thing, they cannot eat this line. Why? Because you need to start from somewhere that, okay, this line will eat this line will eat this, right? If there is at least one different, if there is at least one different and everything is same, 1, 2, 2, 2, 2, then you will have a point. Like, I'm not saying it is in the start, and there is 10 here. So then you have a point to start with. You will start with this, like being eaten by this line. This will become 3. Then one by one, it will eat everything on both sides. So if there is at least one position at which the left and right values are different, you'll have a point to start with. So basically, I'm trying to say is, for this 10, you need to binary search the closest L such that the sum of this part is more than this value, and there is at least one position in this range or subarray which have different values. If these two conditions satisfy, this can be eaten by this line, like by the combination of these line. Is it making sense? Yes, no? Like, easy, right? This is a classic binary search problem, but the thing is, you have to identify these two things on which you are applying, like on what things you are applying binary search. What are the two boundary conditions? And the same thing that you need to do is on the right side. Find the closest right side. See, you cannot do up till this point. Why? Because if you go up till here, the total sum is 9. So these combined cannot eat this. But if you go up till here, then these combined can eat this. Because up till here, the sum is 11. And there is a point at which you can start your, like, this can eat this, and then everything can be eaten. And eventually this will become 11. But let's say there is a 2 here, then the first condition is violated, that, like, everything is not different. Like, the second condition is violated. The first condition is okay, that the sum is more than 10. So you'll have to take further. Like, let's say there was a 1 here, so you could have taken up till here. This is the closest right position towards right, up to which the sum is more than 10 and the value is different at least at one point. So this is what you have to do. And like, even like, can someone tell me what will be the time taken by this combination to eat this? It's simply the number of slimes in this, like the number of elements in this range. So 1, 2, 3, 4, 5, 6, 7. It will take 7 units of time. Why? Because I'm talking about just this side. Why? Because see, this will first get eaten, so 1 is removed. Then these combination will eat this, and eventually this. So how many times? 1, 2, 3, 4, 5, 6, 7. So that's why in 7 units of time, this will be eaten from right side, and from left is, so this will be eaten first, 1, 2, 3, 4, 5, 6, 7, and then 8. So 8. So basically the number of elements on left side and on the right side, minimum of those is the time for this thing. Is it clear? Yes, no. And one thing that you can do is, if let's say you have a value x here and y here and z here, and you see that this value is either less than this or less than this, then directly the answer for this will be 1. If let's say you have a 2 here, 1 here, and 3 here, since you have a value less than on the right side, the answer for this is 1, the answer for this is also 1. Directly you can say it, you don't have to apply binary search. You can apply binary search, that will also give you the right answer, but you can take directly also. Is it clear? Like, because in this part, if x is less than y, both conditions satisfied. That is, the sum of this part is more than this, and these two in this range, there is a position that is different also. So let me show you the implementation. So this is the implementation. First, I'm taking for each test case, I'm taking the number of slimes as input. Then I'm taking their current values as input. This is the prefix sum, and this is the way in which I can find that, okay, if in range L2R, in subarray L2R, is there a position at which two adjacent values differ? So a of I is not equal to a of I minus 1. This is true, like this will give me 1. And in this, I'm adding the previous value. So that is, this will give me count of I is nothing but prefix sum of array, which is having ones in places at which the value differs from last position. And if I calculate prefix sum of this, I can use this later on to get the number of like positions in between L and R, which have different adjacent values, like which differ from their previous value. Answer for every position initially is int max, like not possible. Then I'm iterating through from 1 to n. If I is more than 1 and this value I is less than the previous value, my answer will be directly 1. Otherwise, if I is less than n and the value at I is less than I plus 1, then the value answer at this position is 1. So these two are base conditions. True, like these will be true. Otherwise, I'm applying binary search twice. So in the first binary search, I'm finding the closest left position. So while L is less than equals to R, finding the mid. What is the sum from mid to I minus 1? So from left position, left mid, like whatever I'm trying to find the left most closest positions, right? So from that position, from mid to I minus 1. So how I'm finding sum? By simple, like how we find the sum in previous question also. So if the sum of that part is more than the current value of slime, and okay is not doing nothing but just checking that the position, like the value at this, what like the in this range, there is at least one position which is having value different than its previous value. So how we are doing this? We are doing it like this, like count. In count, we calculated prefix sum, and we are just checking that this value is at least 1. So if it is okay, then my answer is minimum of answer or the number of elements in this subarray I minus mid. And even like accordingly, I shift my boundaries left or right. The same thing is done for finding the rightmost closest position, which I can choose, for which the sum is more than the value of this current slime, and there is at least one position in this subarray or this range which is different than its previous. Finally, I find the sum, I shift my boundary, and eventually what I do for printing answer, if answer I is equals to int max, that way means I was not able to find the answer for this ith line, so I print -1, otherwise I print the answer I. That is the minimum time for this line to be getting eaten. So this is the solution. Is it clear? Yes, no? Okay. No doubts, right? So that's it, yeah. Thanks for joining. Bye-bye.